We are currently witnessing a pretty profound structural shift in how software is engineered. Moving past the overly romanticized hype of AI coding assistants, we're finally stepping into the rigorous realities of autonomous system governance. In this explainer, we'll be unpacking some really fascinating, deeper patterns from rooted layers, AI systems grounded in research. We are exploring a critical mental model today, the transition from informal AI prompts to what's known as the specification surface. It's really about how we actually ground and govern these complex systems for the long haul. Here is a quick roadmap of our methodical approach today. We'll start by unpacking the quiet pull request failure, look into the vibe coding illusion, define the specification surface, talk about closing the coordination gap, transition from passive docs to active invariants, and finally, look at governing the AI future. Let's jump right in. Section 1. The quiet pull request failure, a system without authority. I want you to imagine you're reviewing a pull request in a modern, AI-assisted workflow. On the surface, it looks completely normal. The agent generated a totally plausible diff, the tests are green, maybe a schema was renamed. But then you have to stop and ask the only question that actually matters. What governed this agent? Like, what truly anchored the AI's intent during this seemingly flawless generation? Sure, you have a plausible diff right in front of you, but look closely at the void it leaves behind. There's no maintained statement of what the feature was actually supposed to preserve. There are no unrecorded, settled assumptions. It is honestly the engineering equivalent of having a ghost write a novel for you. The text is literally right there, but the controlling intent remains entirely outside the governed system. So as reviewers, we are left totally in the dark, trying to reconstruct the AI's original intent purely from the symptoms it left behind in the code. Moving to Section 2, the vibe coding illusion, symptoms versus systems. Based on a brilliant 2025 study by Huang and colleagues, we are seeing a clash of two entirely different mental models. The first is what they call vibe coding. This is where intent is privately held in some fleeting chat prompt, and trust is just blindly misplaced in a model's memory. Contrast that with professional control. Experienced developers don't vibe with systems, they exert control over them. They treat intent as a durable public artifact. They maintain a healthy infrastructural skepticism and deliberately push the burden back into reviewable plans. The code is visible. The authority behind the code is not. It's a powerful thought, isn't it? Relying on vague tickets or one-off conversational prompts creates a structurally flawed environment. The simple reality is that code generates significantly faster than human intent can ever be rediscovered. A prompt that just vanishes into your session history simply cannot govern a long-term system. Which brings us to Section 3, the specification surface, our new source of truth. Structurally speaking, a specification surface isn't just a basic README file full of passive advice. Far from it. It is a written surface that actually gains operational force. It is strictly controlled, maintained, typed, and validated. The syntax itself, whether it's Markdown, YAML, plain text, that's secondary. The decisive, absolute, non-negotiable property here is governance. It is the stable artifact against which any generated behavior must be checked. Research by Pascala on spec-driven development completely inverts our traditional hierarchy. Specifications now act as binding contracts. The generated code is no longer the absolute source of truth. It's honestly merely a derivative, downstream artifact that is anchored by tests, contract checks, and active review habits. Let's look at Section 4, closing the coordination gap with some evidence from the lab. Moving into the research lab, there is empirical evidence from a multi-agent study by Chikhan Soratori that reveals exactly what happens when specifications degrade. In single-agent setups, accuracy actually remains pretty stable, but when shared specifications are stripped down from full doc strings to just bare signatures in a multi-agent setup, we see a sharp, immediate degradation. Independent AI workers fundamentally fail to infer those unstated decisions. They desperately need the shared context that a strong specification surface provides. The recovery result from that exact same paper is critical. It proves that merely detecting conflicts post hoc, or after the fact, is totally insufficient. Simply telling agents they have a structural mismatch doesn't fix the system. True recovery, getting back to that single-agent accuracy ceiling, only happens when the full, shared decisions are explicitly restored back to the governing surface. On to Section 5, transitioning from passive docs to active invariants and operationalizing intent. So how do we operationalize this intent? Well, by establishing an operational loop. First, the surface must be controlled, written and properly versioned. Second, it has to be maintained and continually updated as the actual source. Third, evaluated, trace-linked, and audited immediately after execution. And fourth, enforced. Modern frameworks like ContextCov and Agent Specs are pioneering this exact loop. They transform passive instructions, like a simple agents.md file, into active, typed workflows, shell shims, and executable AST constraints. The document literally becomes a source of active invariance. To truly close that loop, downstream verification tools like Fastric and Agent Fixer step in. Fastric refines prompts against tests, while Agent Pex evaluates execution traces for procedural violations that a simple outcome score might entirely miss. Together, they create an evidence surface. This fundamentally changes our mental model, telling the engineering team definitively whether the agent respected the specification and exactly where that specification failed to say enough. Finally, Section 6. Governing the AI future and the practical burden. We have to acknowledge that the practical burdens of governance cannot be ignored. Teams have to consciously decide which surfaces actually deserve authority in the first place. Then you have to keep those surfaces short enough to audit, structured enough for a machine to parse, explicit enough to test, and, crucially, close enough to execution that a violation actually hurts the build or the run. Remember, generated code still carries bugs, latency, and security exposure. Serious engineering teams must maintain this disciplined operational control loop to prevent their systems from quietly drifting into chaos. I want to leave you with this really profound takeaway from the Rooted Layers research. If the answer lives in a maintained artifact that can be read before execution, checked during execution, and repaired after failure, the team has a source of truth. This specification surface is exactly where AI-assisted software work finally becomes governable. So ponder this. In your own workflows, where does your source of truth actually live? And more importantly, can it actively govern your agents?